What if 3i Atlas was not just passing through our solar system? What if it was making a delivery? You have been following this object since July 2025. You know the trajectory anomalies, you know the chemistry, you know the jets. But here's the part of the story that most coverage has not addressed directly. As 3i Atlas moved through the inner solar system, it was shedding organic molecules, water, and fragments of material that had been locked inside it for possibly 10 billion years. Some of that material was directed straight toward the habitable planets: Mars, Earth's orbital path, Venus. And a peer-reviewed study published in March 2026 just proved that life can survive the one physical barrier that scientists always assumed made this impossible. By the end of this video, you are going to understand exactly what was in that material, why the survival question has been answered, and why Avi Loeb is now asking in published scientific papers whether life on Earth was seeded by something that just left our solar system. Hit subscribe, turn on notifications, and let's get into it. As this object carved its path from the outer solar system through perihelion and out toward Jupiter, it was not just passing through, it was shedding gas, dust, organic molecules, water, fragments of material that had been locked inside it for possibly 10 billion years. And some of that material landed in places where life, under the right conditions, could take hold. Harvard astrophysicist Avi Loeb looked at the trajectory, the chemistry, and the timing of that shedding. And in a paper published in May 2026, he raised a possibility that the scientific community is not ready to dismiss and not quite ready to embrace. 3i Atlas may have seeded life in our solar system. Not metaphorically, not speculatively. As a matter of documented physics and documented chemistry. To understand why this idea is scientifically serious, you need to understand what 3i Atlas was actually releasing as it moved through our neighborhood. Start with the organic molecules. After perihelion, NASA's Spherex Space Observatory and the James Webb Space Telescope detected a rich suite of organic compounds streaming off 3i Atlas in its gas plume. The list included methanol, formaldehyde, methane, and ethane. These are not exotic laboratory chemicals. These are molecules that show up in the chemistry of life on Earth. Methanol is used in biological processes. Formaldehyde is a building block for amino acids and sugars. Methane is a biosignature, one of the molecules scientists look for when searching for life on other planets. Ethane is a hydrocarbon that forms under conditions associated with organic chemistry. The production rate of these organic molecules was about 14% of the water molecular production rate. And the water production rate itself had increased by a factor of roughly 20 compared with pre-perihelion observations. So you have an object releasing enormous quantities of water and organic molecules simultaneously in the inner solar system, on a trajectory that brought it within 29 million miles of Mars, within 126 million miles of the Sun, and within 33 million miles of Jupiter. That is not a flyby. That is a delivery run. Now here's where the panspermia theory enters the picture. Panspermia is the idea that life, or the building blocks of life, can travel through space on rocks, comets, and other objects, and seed new worlds when those objects pass close enough to deposit material. It has been a legitimate scientific hypothesis for decades, but it has always faced one central objection: survival. How does anything biological survive the violence of being ejected from a planet, the cold and radiation of space travel, and the heat of atmospheric entry? That objection has been getting systematically dismantled over the past several years. A study published in March 2026 in the journal Astrobiology tested a microorganism called Deinococcus radiodurans under controlled high-pressure impact conditions. Deinococcus radiodurans is already known as the world's most radiation-resistant organism. It can survive radiation doses thousands of times lethal to humans. It can survive complete dehydration. It can survive the vacuum of space. The March 2026 study subjected it to pressures of up to 290,000 pounds per square inch, the kind of force generated when a meteor slams into a planet and blasts surface material into orbit. It survived, cell walls intact, internal structures normal, alive. Stage 1 of the panspermia survival problem, the initial ejection blast, just got crossed off the list. And that changes the entire conversation about what 3i Atlas may have been carrying: Loeb's May 2026 paper laid out the specific mechanism by which 3I Atlas could have seeded life in our solar system. Here's how it works in plain language. As 3I Atlas approached the Sun, solar radiation heated its surface. That heating caused the outer layers of the object to sublimate, going directly from solid ice to gas. That gas carried material with it, including dust, organic compounds, and potentially biological material embedded in the ice. Loeb described this process using an analogy that is worth understanding. He compared it to a dandelion flower shedding its seeds. When a dandelion releases its seeds, it does not aim them. It does not control where they land. It simply releases them into the wind, and the wind carries them wherever conditions allow. 3I Atlas did the same thing. Its sunward jet, the prominent antitail pointing directly toward the inner solar system, acted like the wind. It carried material shed from the surface of 3I Atlas toward the habitable planets in our solar system. The material in that jet included large fragments of water ice and rock that were able to penetrate through solar radiation and solar wind. Some of that material would have been directed toward Mars, some toward Earth, some toward Venus. And if any of that material contained microbes or the chemical precursors to life embedded in ice reservoirs inside the object, those microbes could have survived the journey. Because the March 2026 study proved they can survive the ejection, and earlier research had already shown that microbes can survive inside ice for millions of years, maintaining a tiny film of liquid water around themselves by using oxygen, hydrogen, and methane from nearby air bubbles as a food source. The survival chain is complete. Ejection? Check. Space travel in ice? Check. Delivery to a habitable planet? Check. Now here's the part of the story that Loeb raised as the most important open question. The methane. The James Webb Space Telescope detected methane in the gas plume around 3I Atlas after perihelion. But the timing was wrong. Methane ice is more volatile than carbon dioxide ice. It sublimates at lower temperatures. You would expect methane to appear in the gas plume before carbon dioxide as the object heats up. That is not what happened. Carbon dioxide and carbon monoxide appeared first. Methane only showed up after perihelion, after the object had already made its closest approach to the Sun and was moving away. That sequence suggests the methane was buried deep inside 3I Atlas, protected from solar heating by layers of other material, and only became exposed after the outer layers were stripped away near perihelion. And here's why that matters for the Panspermia question. In the atmospheres of exoplanets, methane is considered a prominent biosignature. A 2022 paper published in the Proceedings of the National Academy of Sciences argued that methane could be the first detectable indication of life beyond Earth. So you have an object that was releasing methane from deep inside its structure at levels far above what is typical for known comets, with a deuterium ratio in that methane about 14 times higher than Comet 67P. Loeb asked the question directly in his paper. Was the methane outgassing of 3I Atlas near the Sun produced by life? He does not claim the answer is yes, but he argues that the question is now scientifically legitimate in a way it was not before the March 2026 Impact Survival Study. Because if life can survive the ejection blast, and if life can survive millions of years inside ice, and if 3I Atlas was releasing methane from deep inside its structure in a pattern consistent with biological activity, then the possibility that something biological was embedded in that object cannot be dismissed on physical grounds alone. Now let's talk about the directed version of this idea. Because Loeb raised two scenarios in his paper. The first is natural panspermia, life or its precursors embedded in 3I Atlas by accident, the result of the object passing through a planetary system where life existed, picking up biological material and carrying it across the galaxy. The second is directed panspermia. An advanced civilization deliberately seeded 3I Atlas with biological material and sent it on a trajectory designed to deposit that material in the habitable zones of other star systems. Loeb pointed to several features of 3I Atlas that are consistent with the directed scenario. The trajectory alignment with the ecliptic plane, which had a probability of occurring by chance of about 0.2%. The sunward jet-pointing material directly toward the habitable planets. The close approaches to Mars, Earth's orbital path, and Jupiter. The perihelion passage hidden from Earth's view. He wrote that this would explain the rare alignment between the trajectory of 3I Atlas and the orbital plane of the habitable planets around the Sun, as well as the sunward jet with large fragments that plowed through the solar radiation and wind. He called the hypothetical civilization behind this an interstellar gardener, and he raised the possibility that if the Vercy-Rubin Observatory discovers additional interstellar objects with a clear statistical preference for the ecliptic plane, the directed panspermia hypothesis will gain a higher likelihood. Because one object aligned with the ecliptic could be a coincidence. Multiple objects aligned with the ecliptic would be a pattern. And patterns have explanations. Here's where the science honestly stands. The organic molecules streaming off 3I Atlas are documented, published, peer-reviewed. The survival of microbes under impact pressures is documented, published, peer-reviewed. The unusual methane release pattern is documented, published, peer-reviewed. The trajectory alignment probability is documented, published, peer-reviewed. What is not documented is whether any of those facts are connected by biology. That question cannot be answered from Earth. It would require a probe sent to intercept 3I Atlas, directed on a crash course toward its surface to sample the material it is shedding, and analyze whether that material carries extrasolar life. Loeb proposed exactly that in his paper. He wrote that by directing a probe on a crash course toward the surface of these icebergs, we can diagnose the composition of the material they shed and infer whether it carries extrasolar life. And then he asked the question that sits at the center of everything. If extrasolar life resembles life as we know it, perhaps life on Earth was seeded by an interstellar gardener. That mission was never launched. 3I Atlas is now heading out of the solar system toward the Gemini constellation at over 130,000 miles per hour. The window is closing, but the material it shed is already here, already in our solar system, already on trajectories that brought it close to the planets where life exists. And the question of what was in that material is one that science now has the tools to take seriously. Whether we choose to look is a different question entirely. If this video got you thinking, subscribe to Space Aquarius so you do not miss what comes next. Leave a comment and tell me which scenario you find more compelling, natural panspermia or directed seeding. And share this with someone who needs to hear that this conversation is happening in peer-reviewed science, not just on the internet.